Hey guys, welcome back to our YouTube channel. Today we are going to be telling you about the Pythagoras Theorem. Before we get into it, don't forget to subscribe to our channel, ping the post notification bell right beside it, and like this video. Also, to share our knowledge, share this video with your friends, family, and educators. So, without further ado, let's get into it. So, as you can see, this is a right-angled triangle. What is a right-angled triangle, you may ask? Well, a right-angled triangle is a triangle with only one angle as a right-angled triangle, a right angle. So, now that you know what a right-angled triangle is, the first property of the Pythagoras theorem is that the Pythagoras theorem holds true only and only in right-angled triangles. If by chance the right angle triangle is maybe it's 89 degree instead of 90 degree, then it will not hold true. So now that we know what the right angle triangle is and how this thing works, let me introduce you to the parts of the triangle. This bottom part over here, the bottom part is known as the base, and the standing line part is known as the perpendicular. So basically, these two parts are on the side of the right angle triangle. Right angle. So you might be like, what do you mean? Well, this slanting side opposite to the right angle is known as the hypotenuse. The hypotenuse is the most important part of the triangle. It is also the longest line of the triangle. You may look at this figure for about 2-3 seconds. I am going to mute my mic. Alright, now that we know the parts of the triangle, let's see what actually the Pythagoras theorem is. Well, the Pythagoras theorem states that perpendicular squared plus base squared equals to hypotenuse squared. What does this square thing means? If you haven't learned about the exponents and power, I will tell you about it. First, let me clear up this whiteboard. So, give me a second. Yes, so being a number, let's say take the number 1 or 10. Take 10 because you're going to get confused with 1. So take the number 10 and say that it is squared. Basically, being squared is like the symbol of being squared, a number being squared is like a little tiny 2 on the top of the number. So being squared is actually the multiplying of the number by itself. So if you want to square the number 10, you have to multiply 10 by itself, which will be 100. So 10 squared equals to 100. Let's take another example, shall we? So if you want to square 3 squared, 3 squared will be 3 into 3 equals to 9. Therefore, 3 squared equals to 9. Now, let's try just one last example, which is, say, 2 squared. 2 squared equals to 2 into 2. As you can see, we're multiplying the number by itself. So that means 2 into 2, which is 4. 2 squared equals to 4. Now, let's actually get into it. So, first we will prove this property. This is a right angle triangle. I'm not drawing it with a scale as of now, but it's a fair right angle triangle. So this is the perpendicular, the standing line. So now let's take the perpendicular to be 3 centimeter. Alright, let's take the base to be 4 centimeter. And let's take the hypotenuse to be 5 centimeter. Now let's actually prove this property. So as we know, p squared plus b squared equals to h squared. So p squared, which is 3 squared plus 2 squared, I'm so sorry, it's 4 squared, right? Yes, so I'm so sorry. P squared, which is 3 centimeter squared plus 4 squared should be equal to 5 squared. So as we know, 3 squared is 3 into 3, which is 9, plus 4 squared is 4 into 4, which is 16, and then 5 squared is 5 into 5, which is 25. Do you know what 9 plus 16 is? Of course you do. It's 25. That proves that this property holds true in this particular right angled triangle. Take a good look at this, guys, because this is the proving property. Alright, feel free to pause the video and watch this explanation again if you didn't get what I mean to say. Now you might ask how this property is useful, like when do we use it in real life? Well, let me give you a story, son. A tree is broken at the height of 5 meters from the ground, and its stalk touches the ground at the distance of 12 meters from the base of the tree. Find the original height of the tree. Now what it means to say is there's a good old tree over here, right? So maybe there's thunderstorm and natural calamities by which the tree has broken, which means this is like this and the other part of the tree is like this, right? So if you remove this bushy part of the tree, it will actually be like this part of the tree and then it's fallen into this part of the tree. Looks familiar? And the base, it says the base, its top touches the ground at a distance of 12 meters from the base of the tree. That means this bottom part is 12 meter. This part is 5 meter. Well, as you can see, this part, the remaining part, is the hypotenuse. So, we are going to find out the hypotenuse because we have to find the original length of the tree. That means the original length of the tree will be hypotenuse plus perpendicular. So, let's get into it. I'm going to write the explanation down. I am also going to be giving you guys a homework question. So, as we know, p squared plus b squared equals to h squared. Now we don't know h squared, but we can find out by adding these two. So p squared, as we know, is 5 meter, right? So we want to square it, 5 meter squared plus it is 12 meter, right? 12 meter squared. So now we want to solve it. So 5 into 5 is 25 meters. Alright, plus 12 into 12 is 144 meters. Okay, I'm sorry, meter. Now, if you add these two, it will actually get hypotenuse squared. Now, this is not the original length of the hypotenuse. If you don't know what I'm meaning to say, let's do 25 plus 144. So, 25 plus 144, if I'm not wrong, is 169. Right, so it's 169. This is the length of hypotenuse squared because it is perpendicular squared plus base squared equals to hypotenuse squared. It does not give the original hypotenuse, it gives hypotenuse squared. Now we have to find the square root of the hypotenuse. So we have to find the square root of 169. You should learn the square root of all the numbers till 1 to 12, and then I'm going to upload a video on how to find the square root. So the next video is going to be how to find the square root. You can refer to that. The link will be in the description box below, and also if you look on the top corner, you will see the link. Alright, so now 169, if you want to do 169 square root, it is 13. Don't worry guys, I'm teaching you how to do this in the next video, or maybe I'll upload it before this video, not sure. So we know now that this is 5. This part, which was the hypotenuse, is 13 and the base is 12. So we have to find the original length of the tree. So the tree was like this. It was standing. It was not tilted like that. No, it was standing. So that means we have to add the perpendicular and the hypotenuse. So obviously 5 plus 13 is 18. So the original height of the tree, which was this, so it was 18 centimeter. This is a question all solved. Now guys, if you have any doubts, please ask me in the comment section down below. I will be happy to solve them. And I'm giving you a challenge, or like you could say homework question for the day. So the homework question for the day is, find the perimeter of the rectangle whose length is 40 centimeter and the diagonal is 41 centimeter. Let me just write it down. So this is the homework question, guys. If you don't understand my handwriting on this whiteboard, I will put it in the comment section down below. So let me just read it out once more. Find the perimeter of a rectangle whose length is 40 centimeter and diagonal is 41 centimeter. It's a very tricky question actually. It's super easy to solve if you understand the term diagonal and length. But that is all for today's video. I will be hearting the comments whose answer is correct. Write the answer in the comment section below. Thank you all for watching this video. Bye.